Hi guys, welcome to Code Bashers. Guys, in this video, I will be discussing the coding question which were asked in Accenture exam today. So earlier today, I have made one more video in which I have discussed one of the coding question, and now in this video, I will be discussing one more coding question that was asked in Accenture exam today, that is on 26th June 2023. So guys, make sure that you are watching this video till the end so that you can get to know what type of questions are getting asked in the exam. So guys, as I have told you earlier today also, I have made the video in which I have discussed one of these questions. You can find the link of that video in this particular playlist with the name Accenture coding question. So here in this particular playlist, I have discussed today's question also, as well as previously asked Accenture questions also. Around 16 to 17 videos are there for coding questions which were previously asked in Accenture. So there will be a lot of repetition in Accenture coding exams. So make sure that you watch this entire playlist so that you can get to know that what type of questions can be asked in Accenture exam. So I hope now this thing is clear to you. And guys, do join our Telegram groups also. The links you will find in the description box. Make sure to join them. So guys, now let's start this video. And before starting the video, please hit that like button as well as the subscribe button for this channel. Thank you. Okay, so guys, the question that we will be discussing in today's video is that add alternate nodes in linked list. So again, a lot of you requested me to make video for this particular question as it was very common in all these slots. So I am making this video now. And if you want me to discuss more such questions, you can directly send me the photos of the questions you want me to discuss. I will pay. I will give my contact details of Telegram on the pinned comment of this video. So make sure that if you want me to discuss some of the questions, you can send me there. Okay. So in this video I will be discussing add alternate nodes in the linked list. So this was asked in slot 1, slot 2 as well as in slot 3. So this question was quite common in all these slots. So make sure that you're watching this video till the end so that you can get to know how to solve this question. So again, first of all, we will be discussing the question, then we will be discussing the approach of this question, and in the later part of the video, I will be writing the code for the same. So do watch this video till the end. Okay, so let's just start with the discussion of the question. So there is a singly linked list represented by the following structure. So this is the structure of the linked list, that is struct node. It will contain data as well as, sorry, it will contain val. So it will contain val as well as the strut node next, that is the pointer to the next node, as we all know in the linked list. Okay, next is implement the following function. Struct node star add alternate nodes, that is strut node. Okay, so we will have to implement this particular function and we will get our head of the linked list as the input to this function, and we will again have to return the head only. Okay, so now we will just have to implement this function. We will not have to take any inputs. We do not have to form any linked list. We just have to implement this function. And what is the functionality of this function? That is given below. The function accepts a pointer to the start of the linked list, as I have told you that the head of the linked list will be input to this particular function head as its argument. Implement the function to modify the given list in such a way that original value of each node is added to the value of next node and return the modified list. So by reading this particular line, nothing will be clear to you that what we have to do exactly in this particular function. So let's just now quickly move towards the note, and then we will move towards the sample test case. The things will become more clear to you after reading those test case. So first is note. So return null if the list is null. So if the input list is null, then we will simply return null. Just modify the input linked list. It means that you do not have to form a new linked list and return the new head. You will just have to modify the current linked list only, and you will have to return the current head only. Okay. Next is first and second node always remain unchanged. So if there is a linked list of length 5, then first and second node value will always remain same. Only the values from 3 to 5 will get changed. Third node to fifth node will get changed. So first two node value always remain unchanged. So I hope now this note is clear to you. Now let's just quickly move towards the sample test cases to see that what exactly we will have to implement in this particular function. So this is our example. Okay, I will go through the example and explanation also given to you. So our input linked list is of length 7, that is here it is given 1, 2, 3, 4, 5, 6, 7. So this is the linked list containing the value, and now we will have to modify this linked list only to give us as give output as this particular thing. So how we will have to modify it, what exactly we have to do with this input linked list, let's just see. With the help of explanation, the things will become more clear to you. Okay, adding original value of the node to its next to next node. So you see, replace value of 3 with 1 plus 3. Okay, replace value of 3 with 1 plus 3. That is, this 3 will become 1 plus 3. This 1 plus 3 is 4. Next is replace the value of 4 with 2 plus 4. So replace the value of 4 with 2 plus 4. This value will be 4 plus 2. That is 2 plus 4 is 6. So we have replaced it with 6. Replace the value of 5 with 3 plus 5. That is, this is the fifth node. We will have to replace this with 5 plus 3. That is, this node plus value of this node is 8. So we have replaced it with 8. 8. Next is replace value 6 with 4 plus 6. So this is the 6th node. We have to replace this value 6 with the 6 plus 4. That is value of this node plus the value of this node. That is 6 plus 4 is 10. Similarly, replace the node 7 with value of 7 plus 5. That is, this node plus this node is 7 plus 5 is 12. So now you can see a pattern that if we are on the current node, we will have to replace the value of the current node with the value of current node plus the 2 before node. That is the node, that is the second last node from here. So if we are at 6 here, we will replace the value of 6 with 2 nodes before, 6 plus 4. This is the 2 nodes before this node, 2 nodes before the current node. So current node is 6, 2 nodes before the current node is 4. So we'll replace the value of 6 with 6 plus 4, that is 10. If we do it for another node also, let's just suppose our current node is 5, we will replace the value of current node with the value of current node plus the value of 2 nodes before, that is 3. So 3 plus 5, we have replaced this 5 with 8. Similarly, if we will see for 4, we will replace this value with the current node value plus the value of the node, that is 2 nodes before. So this 2 node before this 4 node is 2 only. Okay, so therefore 4 plus 2, we have replaced it with 6. So what we have to do, we will have to replace the value of current node with the value of current node plus the value of the node 2 nodes before the current node. Okay, I hope this thing is clear to you. It is very simple. You just have to add the alternate node. That is value of this node. Again, I am giving the example for last ones. The value of this node will be the addition of this node plus the alternate node backwards. Alternate node is this one. So 7 plus 5 gives us 12. So again, to simplify, I am telling you, we will have to add the value of current node with the value of alternate node before it. Alternate node of 7 before it is 5. So therefore 7 plus 5 is 12. Now one thing we have to note, that first and second node value remains unchanged. So here also in output you can see the input and output, first and second node value remains same. So anything that you have to do, anything that you have to make changes is starting from the third node. Okay, so again, the value of current node will be the value of current node plus the alternate node before it, that is 1, 3 plus 1, 4. So I hope now the question is clear to you, and with the help of example the things have become more clear to you. Now let's just quickly jump over towards the approach, because approach is very much important for this particular question, understanding of it, and then only you will be able to code it. So I hope now question is clear to you. Let's just quickly move towards the approach of this question. Okay guys, so now let's just start with the approach part. But if you have not subscribed and liked the channel till now, please subscribe it, because more such videos and more interview experiences in coming days will be posted on this channel. So do stay on this channel and do hit that subscribe button, so that you can get to know the type of videos I am making regarding Accenture. Okay, so before moving ahead, just hit that subscribe button. Okay, so thank you for it. Let's just now see the approach for the same. So this is our linked list 1 2 3 4 5 6 7, and we have to modify this input linked list in the format that I have just discussed above in the example. And as I have told you, the first two nodes of the linked list will remain same, and any changes that we have to do in the linked list will start from the third node onwards. Okay, so again, now how will we start doing changes? Again, I am repeating that what we have to do changes, we have to replace the value of current node with the value of current node plus the alternate node before it. So if we are at 3, so we will add this value of the current node 3 plus the alternate node before it, that is 1. So 3 plus 1 is 4, and we will replace it with 4. So let's just see now how the approach will look like. So what we'll do, we will take 3 variables. One is A, one is B, and one is C. So initially, how we will initialize these variables while declaring initial process. So it is simple, as we all know that the first two nodes value will remain unchanged. So we have taken A, initialized with 1. We have taken B, initialized with 2. Okay, and our iteration will start from third node, as I've told you, because the first two nodes value will remain same. Now we have to do nothing, but what we have to do for every iteration, that is when we are at this node, then when we are at this node, or then when we are at this node, we'll just have to repeat everything that is mentioned here. Okay, so this iteration, now for every iteration we will have to follow this step. So currently we are at 3. So here is the variable c is equivalent to current node's value. So here c is equivalent to current node value, c is equivalent to 3. Okay, next is current node value. In c we have given the current node's value, that is 3. Next thing we have to modify is the current node value. So current node value is equivalent to current node value plus a, as I have told you that this value. So current node's value will be the addition of current node value plus the one alternate node before it, that is 1. So here A is pointing towards 1. So therefore the alternate value is contained in A. So therefore we have done current node value plus A. So we can say that this A pointer for every node will point towards the alternate node before it. So the alternate node before the current node is 1. So therefore A is pointing towards it. And B will be pointing to the one node before the current node. That is A is pointing here to the alternate node and B will be pointing to the one node before the current node. That is 2. So I think this thing is clear to you. So now we will be updating the current node value is equal to current node value plus A. That is A is pointing towards the alternate node. So what we'll do, we'll simply do 3 plus A, that is 3 plus A is 1, that is 4. So we have done, we will replace 4 here. Okay, so we will replace 4 here. Now next thing is, now the work for this particular node, that is the current node, is over. Now what we'll do, we will update our A and B, because we know that A will always point to the alternate node of current node and B will always point towards the one node before the current node. So now we will update in this iteration the value of A. Okay, so A is equivalent to B. So it means that A is also now pointing towards 2. Next is B is equivalent to C. So B was earlier 2, but now C was 3. So B has now started pointing towards 3. And then node is equal to nodes next. So it means that this pointer will move towards the next. Yes, so what we say for the to the next node. So now our A value contains 2 and B value contains 3. That were the original value. So A was here and B now contains 3. Now again we will, for every iteration I have told you, we will update, we will do the same steps. So C is equal to current node value, that is 4. 4 is the value of current node. Next we will update the current node's value, that will be current node value plus A, because A was always pointing to the alternate node. So 4 plus 2, that is 6. So that is 6. So we have updated the value of current node, that is 6. Now what we'll do, we'll update the value of A and B for the next iteration. So A will now point towards B. So A will now become 3 and B will now become C. C was 4. Okay. And then we will do simply node equal to nodes next. So it will now go here. Okay, now again we will simply move towards the iteration. C is equal to current node value, that is 5. Okay, next thing is current node value is equal to current node value plus A, that is 5 plus 3. That will be 5 plus 3 is equal to 8. Okay, now again we will update this value, it will become 8. And now A is equal to B and B is equal to C. So A is equal to B, that is 4, and B is equal to C, that is 5. Okay, so again we'll move to this node to the next node. Next again we'll do the same thing, current node value is equal to 6. Update the current node value, that will be current node value plus A. So 6 plus A, 6 plus 4 is 10. So what we'll do, 6 plus 4 is equivalent to 10. So again A is equal to B, B is equal to C. So A equivalent to B, this is 5, and B is equal to C, C was 6. Oh, B was 6. Okay, now again we will move this thing to, oh, this we have not updated, sorry. This will now become 10, and now we will move one step ahead. That is, this pointer will move towards the 7th thing. So again the current value is 7. current node value plus a, that is 7 plus 5, we should say 12. So it will be 12. Now again it will become 6 and b will become c, that is 7. So this is how we are approaching this question. And now once it will move ahead, it will move out of the linked list. Our linked list is over. And if you will see clearly, this is our output. So this is same as our output: 1 2 4 6 8 10 12, 1 4 1 2 4 6 8 10 12. So I hope now the approach is clear to you. This is how we will be approaching the question. And now if still you have still some doubts regarding question or approach, now let's just quickly move towards the coding part. And one thing to note in coding part is that many you do watch that coding part video till the end, because there will be some changes that you will require to do in Accenture coding part. But the way I have done it, it will not be an issue. But still some changes you will be required to do in the Accenture part, because all those changes depends on the compiler that you are using. So do watch that coding part till the end, okay, and do not skip anything. So let's just now move towards the coding part. Okay, so guys, now let's just start the coding part. But one thing to note in the coding part is that, now see, I am using the lead code compiler. So here the structure of the singly linked list is given as by default as struct list node, and inside this list node star next. But in your Accenture exam, if you will look clearly, the structure of your linked list is given as struct node, and instead of list node, there it is given node. So just this difference is there in my code and in the Accenture code, but like entire approach will remain same. But if you get this question in Accenture exam, do make sure that everywhere that where I have used list node star, you will be using simply node star, because this list node star depends on the compiler. So I'm using lead code compiler, so therefore list node is given here by default. But in Accenture exam, node is given as the you can say variable name. Okay, so wherever I am using in this particular code list node star, you will have to use node star. Again I will give the breaking thing in the caption here. So do not forget to like use node star in Accenture as well as I am using list node, because if you will use list node there, then it will give you the error. Okay, so I have, for saving time, I have already written the code. I will just walk you through that code so that the time can be saved. Okay, but do make sure that instead of using list node star, you will use the name that is given to you in your compiler. Don't make any wrong things here. I am using lead code compiler, therefore using list node star. So I hope now this thing is clear to you. Just update your code based on the name that is given to you in the exam. Okay, so now see this function you will have to implement. As I have told you, you will get the you will get input as head in the function, and you are returning a variable of this type. Okay, so you are simply returning the modified head. So now what we'll do, as we all know that inside like in it is given in the question that first two values of the list remains unchanged, first two values of the node remains unchanged. So therefore, if in the input string, if in the input link list there are 0 nodes or 1 nodes or 2 nodes, because see, if there are 0 nodes, it is given in the question that we will have to simply return null. But we are also given in the question that first and second node remain unchanged. So even if our list has length 1 or list has length 2, we do not have to do any modification in that, and we'll simply return head. So it means that if a linked list contains null value, okay, if it is null, or it contains single node, or it contains double node, in all those cases we will simply return head. We will not do any of the operations, and we will simply return head from here. Okay, so I hope now this thing is clear to you. Now start the main logic. That is, I have told you we will define three variables, that is int a, int b, and int c. Okay, so int a initially will be initialized with the first value. And what is the first value? First value is the value of the head. This is the first value, this is the value of the head. So therefore, we initialize with the first value of a. Next is b pointer, that is b. B I have told you will be initialized with the second value of the linked list. So what is the second value of linked list? So this is our input linked list. First value was initialized by a, so a was 1. Now second value is b, so b is initialized with 2. Okay, so b is, what is b? Heads next val. Okay, so second value is initialized in B. Next thing is, now we have to iterate over our linked list. Starting from the third node, we will have to iterate over our linked list. So therefore, starting from the third node, we have taken a temporary variable with us, which will help us in iterating over the linked list from the third node, not the first and second, but the third node, as I have told you earlier. Now this while loop is used to iterate over the linked list. So while temp, that is while temp is not equivalent to null, we'll keep on iterating this linked list. Now, as I have told you, for every iteration, we will follow some steps. That is this one, as I have written here. That is, these steps we will follow. Let's just see what are these steps. So again, C will be now we have declared int C. So C will be initialized with the value of current node. Then the value of current node will be updated. That is, current node value is equivalent to current node value plus A, because we know that A is pointing towards the alternate node before the C. Okay. Next, after we have updated the current value of the node, then what we'll do, we will update the value of A is equivalent to B, and then we will update the value of B, that is B is equal to C. So it means that our current iteration is over, and then we will simply move towards the next node, that is temp is equal to temps next. So after this while loop is over, so here the updation of A and B is happening for the next iteration. So here when we are updating our A and B, these A and B will be used in the next iteration, that will be on next node, and then we'll simply move towards the next node. So once this loop is over, we'll return head from here. Okay, so this is how our question will progress. But again, keep in mind that here, due to the compiler, by default the name of the linked list is list node star of type. But but in Accenture I have seen, as I've told you earlier, that the linked list is of the type node star. So wherever I have used list node star here, just used node star in your exam. Okay, so I hope this thing is clear to you. Now let's just run one input, that is 1 2 3 4 5. Let's just see whether our code is running fine or not. In Accenture, you will just have to implement this function. No need to worry about how the input is coming, how the output is flowing. Just implement the function. So once we have done 1 2 3 4 5, so you can see our updated output, that is 1 2 4 6 8. And if we now let's just do 6 and 8, 6 and 7 also here, then also you will see that it will give the correct answer, that is 1 2 4 6 8 10 12. So guys, this was it for this video. I hope you liked the video, and do hit that like and subscribe button for this channel, and do share this video among your friends so that they can also prepare for the Accenture exam. And guys, do subscribe this channel because it motivates me. And if you want to contact me and share some of the questions that you would like to get posted on this channel, so I will give you my contact details on the pinned comment below. So do use that path to connect to me. So thank you for watching this video.